Hey everybody, wanted to go over the Alchemy 3 review assignment and a little bit of the stuff that we covered over the Alchemy 3 unit. So just talking about the review assignment real quick. The beginning 4 questions, or I guess 3 questions that ask you to describe the different scientists and the models they proposed. You're going to need this sheet right here, Atomic Pudding. Okay, it's got the evidence here that you can see. And then it's also got, actually this other sheet are the models that go along with that. So you're going to need those 2 sheets in order to answer those questions. Next couple questions kind of go over things, just basic information that you should know from this Atomic Pudding assignment that we did. Or sorry, atoms by numbers, there it is. So use that one to answer those questions, kind of refresh your memory. I do want to go over some of the basics with the periodic table and what information you're getting here. Remember that, let's take selenium for example here. This 34 here is the atomic number. That tells us the number of protons and electrons, right? So I know that selenium's got 34 protons, it's also got 34 electrons. It means it has a total charge of 0 because 34 protons minus 34 electrons equals a 0 charge, right? So this number over here is the average atomic mass. Okay, that's an average number. So if I wanted to find out how many neutrons selenium had, what I'd have to do is round that number. That's my mass. So I would have to take, I'll just erase this over here. I'd have to take 78.96, round it up to 79. And then if I want the neutrons, I got to subtract 34 from it because those are the protons, okay? So now I take that. I know this must have 45 neutrons, okay? So that's how you find the neutrons there. When you are looking at an isotope symbol for something, that's kind of the next part of the review assignment. Let's take selenium again. I could have 2 possible isotopes for selenium here. One would be, I'd round that up to 79, so it would be called selenium 79. Okay, that's the isotope name for it. And then the symbol, if I want to make the symbol for it, it would be selenium, and the atomic number for selenium is 34, and the mass for that isotope would be 79. Okay, so again, if I want to find the neutrons there for that one, I'd have to just subtract those 2 numbers, and I showed you that was 45. I could also have another isotope here, selenium 78. Okay, so if I rounded that down, I could round it down to 78. That'd be selenium 78. The isotope symbol for that one would be, again, selenium. Still has 34 protons, but this time the mass would be 78. Okay, so now the question is, out of these 2 isotopes, which of these 2 isotopes of selenium is going to be more common? Which are you more likely to find? And the answer is selenium 79, because the average mass is closer to 79 than it is to 78. So this would be the one that you'd more often find in nature. All right? Nuclear reactions. Let me move my computer over a little bit so you can see. Wanted to go over just the basic types of nuclear reactions. Okay? Nuclear reactions, big thing to remember, fission and fusion, right? So those are the 2 types. Fission, meaning you start with something and you split it in half. That's fission. And then fusion is where you have 2 things that are separate and you join them together. They fuse together. Okay? So there's 2 types of fission reactions that we've talked about. One is alpha decay. That's where it basically just breaks down. So let's say we start with boron. Okay? So in alpha decay, we're always going to get this. It's called the alpha particle. Sometimes it's written like this, like a Greek letter A. Okay, so that's the alpha particle. And now I got to figure out what would be left over after that broke down. Okay, let me draw a little line here. So I got to say 2 plus something has got to give me 5. So that's going to be 3. Okay, what element's number 3 on your periodic table? That's going to be lithium. Okay, so what's my mass that I'm left over with? 4 plus something has to equal 7. It's going to be, I'm sorry, 4 plus something has to equal 11. That's going to be 7. So we would have our boron breaking up into the alpha particle and the lithium atom that would be left over. Okay. For beta decay, sometimes that's written as a B that looks a little bit like that. So beta decay, it's going to break down again, and in this case, it's going to form the beta particle, which is basically an electron there. And so now we got to look at, okay, -1 plus something has to equal 5. Answer there's 6. 6 minus 1, 5. Okay, so that element is going to be carbon. And then 0 plus something equals 11. Well, that's going to be 11. So when boron goes through beta decay, it becomes carbon, 11. And it loses the beta particle too. Now fusion, on the other hand, is where we start with two things and we fuse them together to make one new thing. So we've got boron, carbon. We're going to fuse them together in a nuclear reaction to make 5 and 6 is 11, so that's element number 11, sodium. And the mass for that's going to be 11 plus 12, which is going to be 23. Okay, sodium 23. All right. If you have questions, email me at my email. I'll try and check it pretty often so I can get your questions answered. fritbr01@southredford.net. And you can also check online the online textbook if you want more practice with these kinds of problems. Okay? Have a good night. Or day.